Agni, the fire, is the most potent source of light and heat energy. Since hundreds of millennia, fire has significantly contributed to the progress of humankind on the path towards civilization. It has banished darkness and provided knowledge, helped shape things of daily use, and aided societies to keep on the move. How did fire come into being? And how did man learn to use it? There are no definite answers to these questions. Blazes ignited by volcanic conflagration and lightning are speculated to have served as man's first source of fire. From such terrifying blazes, primitive man is believed to have kindled his own fire over 5 lakh years ago and gradually become conversant in using it for various purposes, such as to keep himself warm, to hunt animals, and to cook food. Much later, in the Neolithic age, he used fire to clear forests for agriculture and human settlements, and also learned to make fire by striking flints together, or by using simple tools such as the fire saw, the fire plow, and the fire drill. Since then, the application of fire has brought about significant changes in man's ways of living. In particular, it was the application of fire in pottery, in extraction of metals, and in their conversion into alloys that led to the emergence of the Metal Ages. For the growth of civilizations in ancient Greece, Egypt, and the Indus Valley, and of course for the industrial revolutions of the last few centuries, fire has immensely contributed. But fire, which has benevolent and destructive powers, was a mystery to the ancient people. They believed it to be of heavenly origin. According to Greek mythology, fire was stolen by Prometheus for the good of his fellow beings. The Persians interpreted fire as a true gift of the gods, fit to be venerated and worshipped.
Agnimele purohitai yajnasya deva mritwijam hotaram ratnadhatam aggaswaha.
The Vedic societies looked upon Agni the fire as a divine being who resides everywhere, despising none. He is the possessor of power and wealth, and the divine messenger between the god and human beings. As did the Vedic mystics, the Greek philosophers, Plato and Aristotle, thought fire to be an element essential for the constitution of life and matter. Such mystical ideas prevailed until the later 18th century, by which time scientists had discovered the essentiality of air for the occurrence and persistence of fire. Antoine Lavoisier, in 1772, showed that an active fraction of air combines with burning substances, making them weigh more than they initially did. Fire, he explained, is the result of a chemical reaction between oxygen and flammable substances.
The complex phenomenon of fire is basically a manifestation of combustion. Combustion can be defined as an extremely rapid chemical reaction in which a combustible substance combines with oxygen from the air, producing combustion products along with the emission of heat and light in the form of flame.
Not all combustions, however, result in fire. Often oxygen unites with some substances at such a slow rate that little heat or no light are given off. Such a slow reaction is called a slow combustion rather than burning, which is very rapid. A good example is the rusting of iron.
Before we go into the details of chemical reactions involving flammable vapors and oxygen that yield fire, let us look at the conditions needed for fire to occur.
First, there should be a fuel. Most fuels are complex hydrocarbon compounds. A fuel could be a solid such as coal or wood, a liquid such as oils, and a gas such as methane. Second, there must be plenty of oxygen. Third, the fuels must be heated to ignition temperature at which they undergo thermal decomposition, releasing flammable vapors with which oxygen unites rapidly in a chemical reaction. In fact, all fuels, except gases, must first be converted to their gaseous state for them to yield fire. It is therefore that kerosene, a liquid fuel, though exposed to air, will not catch fire even when a pilot flame is brought in contact with it. However, upon heating directly to its ignition temperature, kerosene converts into its vaporous state. Now, when a burning stick is brought close to the vapors, they combust readily into a flame. In the case of combustible solids, heat decomposes involatile fuel molecules into tiny volatile molecular fragments which react with oxygen of the air to yield fire, producing a series of combustion products.
Let us investigate chemical reactions by taking the example of methane and oxygen.
Each molecule of oxygen contains two oxygen atoms which are bonded together. Methane is a natural gas. Each of its molecule contains one carbon and four hydrogen atoms bonded together in a particular arrangement by a force arising from electron sharing, which accounts for the molecular energy. When methane is ignited, the bonds break, freeing carbon and hydrogen atoms, which then react separately with oxygen. One carbon and one oxygen atom unite to form carbon monoxide. One oxygen and one hydrogen atom combine to form the hydroxyl radical. While carbon monoxide combines with one oxygen atom to form carbon dioxide, the hydroxyl radical unites with one hydrogen atom to form water. These products of combustion then escape into the atmosphere.
The total energy of combustion products tends to be less than those of the fuel and oxygen involved in combustion. The difference in energy